This tower is a pinnacle of modern engineering. It's more than half a mile high.
This has never been done at this scale before anywhere in the world.
Dubai's Burj Khalifa is the world's tallest building. Weighing in at more than 500,000 tons, the desert skyscraper contains enough steel to stretch a quarter of the way around the world. But without a revolutionary internal structure, it wouldn't even stand up.
You couldn't take what had been done in other buildings and just enlarge them. It doesn't work.
It's so daring that during construction, designers tore up their plans and upped the ambition.
We were able to go much higher than we started, and it kept on getting taller and taller.
Today, it's the tower against which all others are judged.
Every time I come here, it's like I'm actually in awe of what we did.
Much of what is incredibly innovative about the Burj Khalifa you will never see at the building itself because it's all hidden away behind the facade.
The only way to find out how this superstructure became reality is to take it apart and uncover its engineering secrets. The Burj Khalifa is an unbelievable 2,717 feet tall. This megatower was designed as the centerpiece for a new global city.
The development of the UAE was reliant on its oil wealth. But as this diminishes, they need to future-proof themselves. And so what they're doing is making the area a destination to visit for entirely different reasons. Who wouldn't want to say that they visited the tallest building in the world?
Dubai's central location makes it an ideal spot to attract tourists from both Europe and Asia. But it's also one of the most unsuitable places on Earth to build skyscrapers, thanks to the unforgiving conditions of the Arabian desert.
Dubai is one of the toughest places to build anything, let alone the tallest building in the world. It's extremely hot and it's extremely dry.
Back when the Burj was first dreamt up in 2003, this part of Dubai was little more than sand. To bring this ambitious project to life, a team of the world's best engineers is assembled, led by skyscraper expert Bill Baker.
Whenever you start a project in a new location, you need to find out what are you going to be sitting on. Are you on sand? Are you on rock? Are you on clay?
When Bill and his team investigate the site for the tower, they drill hundreds of feet down into the ground. Their results could not have been worse.
What we found, what was down there was a sedimentary rock. So it's a rock. It's not like a strong limestone or granite. The rock is called calcisiltite. So to take that word apart, calcia is like seashells. So silt means dust-like particle. So let's call it seashell dust.
The tower is in serious trouble before construction even begins.
A building of this size will weigh a huge amount and will also require extremely solid foundations. These are difficult to achieve when you're digging down into a sandy environment because there's no bedrock to lock that building into.
As time passes, the building could settle, which is to say one part of the building starts to sink. And in that case, you have a very serious problem. Houses can settle. You can go back into a settling house and jack it up. You cannot jack up the world's tallest building and simultaneously one of the world's heaviest buildings.
Without solid foundations, buildings can't support themselves. Italy's famous Leaning Tower of Pisa. It's built on top of weak sandy soil with measly 10-foot foundations. It didn't stand a chance. Chicago's Monadnock building sits atop swampy, soft ground. It's sunk by 21 inches since it was built in 1891. And in less than a decade, the Millennium Tower in San Francisco has sunk by 18 inches. And worse still, it's tilting northwest by more than a foot, cracking dangerously.
The Burj Khalifa is incredibly heavy. The base of the building actually carries the weight of the building itself, which means that the bottom is carrying all the weight of the entire building above it. This has never been done at this scale before anywhere in the world.
Once complete, it will weigh more than 500,000 tons. With no solid bedrock to anchor it into, Bill and his team are forced to rethink. The solution they come up with is ingenious. The Burj sits atop a gigantic 12-foot thick slab of concrete, which is sunk 24 feet below the surface. It covers a massive 80,000 square feet, the same as 28.5 tennis courts. It's known as a raft foundation because it floats in the soft ground, cleverly spreading the colossal weight of the tower across a large surface area.
Now, if you think about it, if you're out in the summer walking on grass and you've got stiletto heels on, we all know that the heels are going to dig straight in and you kind of want to fall over backwards. But if you had a flat trainer on instead, that doesn't happen. And the reason is that your weight is being nicely distributed and spread across a larger area, so the pressure is lower. Whereas in a stiletto, there's lots of weight on a very concentrated point.
The raft foundation spreads the weight incredibly well, but the raft itself has to be kept in position. Any shift sideways, and the tower could start to list and eventually topple. The raft is secured by 194 concrete piles, each 5 feet in diameter. They reach more than 164 feet down through the soft ground. But unlike traditional piles, they never reach solid rock. Instead, they rely on friction to hold them in place.
Friction is a really surprisingly strong force. Although any one of those foundations, which are just going into sand, isn't able to support a huge amount of force being exerted on it, if you have enough of those piles, which have a tiny bit of friction on each one, then collectively they can support the enormous weight of this building.
Despite the desert's best efforts to thwart them, Bill and his team lay some truly remarkable foundations.
The building settled very little, somewhere between 40 and 50 millimeters, which is a little less than 2 inches. So, my thumb is 1 inch thick, okay? And so the building settled a little bit less than 2 thumbs, to give you an idea of how much this building went down. So it's a very good foundation.
The engineers have overcome the problem of the unstable desert ground, but they still have more than half a mile to go vertically. Strong foundations aren't enough on their own to keep the world's tallest building standing. Just as important are the load-bearing solutions hidden inside the tower itself.
We think of skyscrapers as buildings built out of a metal frame with a glass curtain wall hanging from it. But the Burj Khalifa is actually site-cast concrete.
It's the ideal material to construct the Burj Khalifa with. Dubai is known for its well-established concrete industry. Concrete is also incredibly quick to build with, thanks to the use of a mold called a jump form.
The jump form is made up of a series of walls that are generally made from wood, but then they've got lots of hydraulic legs and arms which basically prop it up to create a mold into which you then pour the liquid concrete. Then the concrete can harden, it can set.
Once the concrete is set, the mold is jacked up to the next level and the process begins again.
With a traditional formwork system, you'll probably be looking at 6 or 7 days to do one story. On the Burj, we were typically operating on 3 days of floor, and we even achieved 2.5 days at times.
Speed is crucial. Even amidst concerns about low pay and poor conditions for the migrant workforce, every day of construction costs hundreds of thousands of dollars. The tower shoots up at a phenomenal speed. But as it gets taller, construction becomes more and more difficult.
pumping concrete to a height of 610 meters. Well, it just hadn't been done before. It hadn't needed to be done.
But it needs to be done now, and quickly. Constructing the world's tallest building isn't easy. Every stage and every process must be supersized.
One of the challenges is just getting the construction materials up to the height where they're required. So right on ground level, but imagine you're trying to pump concrete up dozens of stories.
It takes about a minute to pump concrete up 50 feet. So to get to the upper levels of the Burj Khalifa, it will be in the pipes for more than half an hour, which is a big problem.
It can start to harden, and that would be really, really bad for the pumps. It would essentially cause the pumps to fail.
If the pumps fail, construction will grind to a halt. To prevent a catastrophe, engineers must create an entirely new type of concrete, specific to the Burj.
So they can add what we call admixtures, so they're little chemicals that we mix into the concrete to change its properties to make sure that the concrete you're using is liquid enough and kind of plastic enough that it can actually be pumped to those heights before it hardens.
After weeks of testing, the perfect mix is made, but it still isn't enough to get the concrete where it's needed. To avoid it hardening too quickly in the searing desert heat, the concrete must be made with ice and only pumped at night. The most powerful pumps on Earth are brought to Dubai to do the heavy lifting.
They use this amazing pump called a Putzmeister, a great name for a concrete pump. Putzmeister was able to actually, in one single lift, pump the concrete from the base of the building all the way up to 600 meters.
Pumping concrete to a height of nearly 2,000 feet sets a new world record, the first of many for the Burj Khalifa. At the center now stands a hexagonal concrete core that stretches almost the entire height of the building. Inside the concrete are enough steel reinforcement bars to stretch a quarter of the way around the planet. But the Burj's unparalleled height once again presents a problem.
This concrete shaft core by itself is too slender to go to such great heights.
Without a helping hand, it could not stand up.
You couldn't take what had been done in other buildings and just enlarge them, okay? Just like you can't take a small animal and make them the size of an elephant. You know, it doesn't work. We had to come up with a different structural system, a different solution, a different system.
Bill's new system is inspired by centuries-old cathedrals, where the main building is supported by buttresses. The Burj Khalifa has 3 such buttresses, which wrap around the central core. Their ingenious positioning helps them dissipate the loading forces away from the core and spread them over the full area of the foundation slab. It's the first time this configuration has ever been used on a skyscraper.
If the huge load coming down the center of the tower wasn't spread out in the way that it is, the amount of stress going onto the ground would have been much, much higher.
With the supportive buttresses taking shape, and with the problem of the concrete solved, the Burj flies ever higher. But the taller it gets, the more dangerous it becomes for the workers. Steel cages are used to transport people to the highest levels. And as soon as a level is complete, a fence is erected along the edge. Tragically, at least 3 contractors die during construction. Today, workers still have to brave the extreme heights to do their jobs.
We are at level 109. We are above the Armani entrance. We have a task of cleaning this part of the facade.
It takes 3 months to wash the building from top to bottom. And it's all done by hand.
We have 36 Spider-Man that goes outside to clean our windows. And honestly, you need to have nerves of steel to be able to go outside.
Thankfully for these men, climbing extraordinary heights is in their blood, because they have come all the way from Nepal.
Where else other than the Nepal, where we have the Himalayas, to bring our rope access technicians from? Every time I meet with them and I'll tell them, how did you feel today? Just another day, sir, you know? Just another day.
Each man is attached to the building by 3 ropes, and the conditions are carefully monitored.
Today it is extremely windy. We are now at roughly 19 knots, and we normally cease our operation at 12.
With the wind picking up, the men are in real danger. Keeping the world's tallest building, the Burj Khalifa, looking its best is a full-time job, made all the harder by the extreme height and challenging conditions.
21, 22, 1, 2, 1, 2.
22 knots is over 25 miles per hour, strong enough to send the ropes and equipment flying into the glass.
It is extremely windy. We have to stop now. We're calling them back in.
The wind isn't just a danger for the workers, it could also shake the entire building apart, were it not for some very clever engineering. By 2007, 3 years after breaking ground, the Burj Khalifa is well on its way to becoming the tallest building in the world. It's already taller than the Empire State Building, and there are tens of stories to go. But the taller it gets, the more danger it's in. Here in the Arabian desert, epic sandstorms are a constant threat. The high winds bring with them thick clouds of red sand, causing havoc on the roads and shutting the airports. Such apocalyptic storms are rare, but in summer, Dubai is often hit by strong northwesterly winds. They can reach speeds of more than 50 miles per hour and pose a serious danger to the Burj.
Wind is going to be a problem for any tall building, but when a building is this tall, it's an even bigger issue.
The classic shape of a skyscraper is a huge, well, basically rectangular face, and that is an absolute disaster from an aerodynamic perspective.
When the wind pushes against any building that's of a constant dimension from top to bottom, it'll create these things called vortices, little swirls in the air that come off one side and the other.
As those vortices get generated, they create low pressure regions which push on the building or suck on the building. And if you don't design the building right, those forces can cause the building to sway and shake.
1940. Wind hitting the flat face of the Tacoma Narrows suspension bridge causes vortex shedding, contributing to its spectacular downfall just months after it opened. And in 1965, high winds destroy 3 cooling towers at a power plant in England. To prevent a similar disaster in Dubai, Chief Engineer Bill Baker tested the mega tower's design extensively before any building work began.
So we went in the wind tunnel, we got the test data, and the data was not good at all. The building was moving too much, the forces were too large.
The team had to do something to reduce the sway.
Tall buildings have, for much of the 20th century, used a very basic mechanism to deal with building sway, which is you have a very tall weight hoisted to the top of the building that sits in a kind of sling and is designed to counterbalance any movement of the building.
It's called a mass damper and is the system used by Taipei 101, the previous holder of the tallest building world record.
So if the building begins to sway a little bit too much to the east, the counterbalance will move to the west in order to help the building stay righted. It doesn't keep the building from swaying, but it keeps it from swaying too much.
Taipei 101's damper works well. In 2015, It swung into action during a typhoon that brought with it winds of 115 miles per hour. But its protection comes at a price.
The mass damper in the Taipei 101 building takes up 6 floors. They simply didn't want to waste that kind of space in the Burj Khalifa, so they've cleverly designed it to avoid the need.
Bill came up with an unconventional idea that both tamed the forces of the wind and removed the need for a giant damper in one fell swoop.
The way we addressed the problem here was to reduce the forces. What we did is we reshaped the building.
When you look at the Burj, the first thing you see is not a traditionally shaped skyscraper. It's got a very unusual cross-section. And as you move up the Burj, that cross-section changes. It rotates, it changes size.
The tower takes its shape from a desert lily, with 3 petals giving it a unique Y-shaped footprint. It gets narrower as it rises, and it spirals round, so no single face runs its entire height.
It's almost like lots of different height skyscrapers all fused together.
The result is that when the wind hits the Burj, it reacts with different levels in different ways. And that means the vortices are different at different heights. So instead of having one massive coherent vortex that can exert a huge force, you have lots of much smaller ones.
And what that means is that these vortices can't really ever get a strong grip on the building and do damage to it.
When Bill returned to the wind tunnel, the results were shocking. And the final height of the Burj Khalifa was drastically revised. This observation deck on floor 148 of the Burj Khalifa is more than 1,800 feet high. Hundreds of people flock here every day, drawn by the building's jaw-dropping height. But this mega skyscraper was never supposed to be this tall.
To be the tallest, this was not our aim at the beginning. The aim was doing spectacular project.
As the engineers change the shape of the building to help counteract the wind, they discover a surprising side effect.
Because of the way we tuned the building, the way it moves, so that it doesn't amplify forces that we're seeing from the wind, we could go much higher than we started. It kept on getting taller and taller, even after the foundations were in and the bottom of the building had been started.
Changing the final height after construction has already begun is a bold move.
The tallest tower here in Dubai was only 33 floors. So imagine where we are now today. So for me, it was really like a dream.
But the extra height brings with it a new problem. As well as the tourists that visit it, thousands of people live and work in the Burj. The building's capacity is 35,000 people, the equivalent of a small city.
One of the most important parts of a city is the transport network, and that's absolutely critical if you've got a vertical city like the Burj.
One of the major challenges in a tall building is how do you move people through it efficiently and quickly?
Stairs are impractical, although the Burj has plenty of them, nearly 3,000 in fact.
When it comes to vertical living, elevators really are the key.
But once again, the tower's extreme height means the solution isn't as simple as it seems.
In the past, the obvious solution many came to when thinking about tall buildings was to simply make sure every elevator went to every floor all throughout the building. And that at first seems to make sense. But if you've ever been in a hotel during checkout time on a Saturday morning and you were on the 7th floor of a 7-story building, you learn quickly that you will stop at every single floor. Your 30-second ride to the lobby is now a 3.5-minute ride. And that seems like an eternity. Now, magnify that by 160 stories.
To save everyone from spending half their day in the lifts, engineers turn to a solution inspired by city commuting.
You have express trains and you have local trains. And the express train takes you the 90 blocks you don't want to stop at. And you get off and take a local for the last 2 or 3 blocks that you really intend to get to. You can do the same thing with elevators.
Right in the heart of the building, nestled in the concrete core, are 57 elevators. 8 of these are express elevators, that only stop at floors 43, 76, and 123, the so-called sky lobbies. From here, people can take one of the local elevators to all the floors in between. To make the system even more efficient, 2 of the elevators are double-deckers. So as tourists make their way to the observation deck on level 148, others are riding to their offices in the car above.
We're in the heart of Burj Khalifa at this moment. Next to me you see one of the biggest machines, or the biggest machines we have in the world, driving a double-deck elevator.
The lifts in the Burj are some of the fastest in the world, whisking people hundreds of feet up and down at 22 miles per hour.
The acceleration and deceleration of the elevators is controlled in detail. The idea of the experience is to let people not feel the movement.
This phenomenal speed also serves another purpose. The lift forms part of an evacuation plan that turns conventional wisdom on its head.
Everyone knows that in case of fire, you never take the elevator and you always take the stairs. But the Burj Khalifa is a bit different.
One particular elevator has an incredible travel of 138 floors, more than any other elevator in any other building in the world. This is the Burj's lifeboat. It is encased in thick, fire-resistant concrete and can take 26 people at a time safely down to the ground in less than a minute. Having a fail-safe emergency plan in place is more important here than anywhere.
I think the prospect of being stuck 160 floors up in the air, should anything happen, petrifies me.
Just next door to the Burj Khalifa is the Address Tower, a 63-story hotel and residential skyscraper. New Year's Eve 2015. The Address is engulfed in flames hundreds of feet tall after an electrical fire breaks out. In 2017, another Dubai tower, the unfortunately named Marina Torch, has to be evacuated after it too catches fire, for the second time in 2 years. Hundreds of terrified residents are forced to flee for their lives.
They actually came around pounding on our door and telling us to get out, so that's when we knew to leave.
The Burj is twice as tall as the Torch and can hold thousands more people. Evacuating them all in the event of a fire would take far too long. So instead, engineers have designed the building itself to keep people safe for as long as possible.
They've created what we call refuge areas. So that means that people can go down a few levels of stairs, but then they're into these encased, enclosed rooms that, smoke can't infiltrate into them. They've got fresh air supplies, and they're fireproof.
These safe havens only work if people can reach them. The stairwells must be kept clear. Today, a routine test will see if the tower's specially designed smoke suppression system is working properly.
Ideally, this is a fire exit route, and it needs to be safe for whomever is using it.
In the event of a fire, fresh air is pumped into the stairwells at a higher than normal pressure. It creates an invisible barrier at the thresholds, preventing any smoke from getting past.
Although we have the machine very close to the door, the smoke won't enter.
Hopefully, none of the Burj Khalifa's safety equipment will ever need to be used. But here in the desert, the most dangerous heat doesn't necessarily come from fire. May 2007. Construction of the Burj Khalifa has been underway for 3 years. The tower is now nearly 1,500 feet tall, and a new stage of building begins. the installation of the glass curtain wall.
Just like people, on a tall building, you need a skin to protect it from the elements. Here you see the cladding of the building, the curtain wall.
The Burj's skin is made of glass and aluminium.
The individual glass frames sit within metal frames and are actually assembled off-site and then are brought onto the construction site as prefabricated systems.
The panels must be hung one by one. Positioning all 26,000 of them takes 2.5 years. By September 2009, all the Burj Khalifa's cladding is firmly in place. There is more than 1 million square feet of glass, enough to cover an American football field, 20 times over. But all this glass creates a new problem for the Burj. Temperatures here in Dubai regularly hit a sweltering 120 degrees Fahrenheit and more. Keeping cool takes serious effort, especially inside a giant glass building like the Burj Khalifa.
The surface temperature can get quite hot, almost as hot as boiling water.
If you think about an all-glass building in an incredibly hot climate where the sun is shining all day long, what you would have is the inside of your building would get incredibly hot, in fact, lethally hot, within a few hours.
But thanks to some clever technology within the glass itself, the mega tower doesn't act like a giant greenhouse.
Now, when you look at this building, it sparkles. All that sparkle is the solar energy that's not going into the building. It's being reflected off.
You have a pane of glass on the interior and a secondary pane of glass on the exterior coated with metal. The metal gives it reflective quality from the light.
These special coatings reflect more than 70% of the sun's heat. But the Burj needs more than just sunglasses to help it keep its cool. Stripping away the layers of the Burj Khalifa reveals miles of ducting, which carry cold air all around the tower. Wherever you are in the building, you are never more than a few feet away from an air vent. Moving this air around such a gargantuan skyscraper requires some serious grunt. So every few hundred feet, the tower has an enormous double-decker mechanical floor, which houses pumps so powerful, together they could inflate 13 hot air balloons in just a minute. But the Burj contains more than 65 million cubic feet of air. Cooling it all requires more machinery than even this giant building can accommodate.
The solution was to build a chiller plant, not just one, but two, off-site, to provide the cold water that cools the air.
This building might look like an Arabic fortress, but it is actually a high-tech cooling plant that supplies cold water for air conditioning to the Burj Khalifa. 250,000 gallons of water a day pass through these giant heat exchangers before being pumped to the Burj through underground pipes.
We receive the chilled water temperature at as low as 3 degrees centigrade.
It's used to cool more water inside the skyscraper's own heat exchangers.
This is a whole room full of machines dedicated for air conditioning. This is the main one out of 14 we have across the building. If we lose them, we lose the cooling, period.
The air conditioning system isn't just for comfort. Without it, the building will quickly heat up to deadly temperatures.
When the temperature hits 50 degrees outside, the maximum you can sustain it is roughly 2 hours.
Keeping the tower habitable is essential, because it's not just a tourist attraction. For some lucky people, it's home.
It's more than just a statement. It's vertical living at its best. It's an engineering masterpiece.
The Burj Khalifa has 160 habitable stories, with more than 3 million square feet of mixed-use floor space.
There's hotels, there's offices, there's residential, there's shops, all kinds of things.
Our gorgeous, beautiful terrace. Now tell me, isn't this amazing? You feel like you're in heaven, really.
One of the most important parts of a city is services: water, gas, electricity, sewage. And if your city's vertical, then you've got to move all of that stuff vertically up and down to get them where they need to be.
Supplying a regular city with the amenities it needs is tricky enough. But here at the Burj, the problem is made much, much worse, thanks to the inescapable force of gravity.
160 floors is an awful lot of people, and all of those people require water, just living their lives and sleeping and washing and scrubbing their teeth.
The tower uses a colossal amount of water, 250,000 gallons a day.
If we were trying to move that quantity of water horizontally across the ground, then that wouldn't be that challenging.
But moving it upwards is. 1 gallon of water weighs around 8 pounds. So every day, the Burj Khalifa needs to lift 1,000 tons of it.
Trying to pressurize that water to go all the way up in one hit would be very, very difficult, very expensive, and just create too much of an energy demand.
Hidden inside the Burj's 14 mechanical floors are huge water storage tanks. Mains water is fed into the tanks at the bottom of the building, before being pumped up the building in stages, through 62 miles of pipes. At each stage, water is held in the tanks until needed, when it is gravity-fed to taps and cisterns on the floors below. But what goes up must come down.
In your home, wastewater, it just travels naturally by gravity. But in high buildings, you don't want it all cascading the full height of the building. Enormous pressure would be built up in the pipes.
If wastewater fell unchecked, it would be traveling at over 100 miles per hour by the time it reached the ground. So it is also carefully moved in stages.
That's managed by sewage holding tanks. So it drains into a tank a few floors below and then pumped out in a controlled way.
And the entire water system is soundproofed, so residents can't hear any machinations. But here, their comfort isn't the only consideration. In July 2007, the Burj Khalifa becomes the world's tallest building. But it keeps rising. 9 months later, it becomes the tallest man-made structure on Earth. But it still isn't done growing. Its crowning glory is to be a 700-foot metal spire.
The contractor couldn't get a crane that high to place the spire. So what we decided to assemble the spire down inside the building. Then it was launched from the inside the building and then came out to the top.
With the spire in place, the Burj is now its full and final height. A mind-blowing 2,717 feet. That's half a mile tall. There is nothing on Earth anywhere close to this tall. It's nearly twice the height of the Empire State Building, and its nearest rival, China's Shanghai Tower, is 600 feet shorter. But its extraordinary height has turned it into a target.
You might say that the Burj Khalifa is the lightning rod for Dubai. The spire gets hit quite often.
Dubai can be battered by terrible storms. And each one can potentially bring lightning strikes.
A thunderstorm cloud can contain 100 million volts. So if just one bolt of lightning hits a building, it could be immensely destructive.
With a building as unprecedentedly tall as the Burj, they didn't have the data even to work out how many or how large a strikes to expect.
For the Burj, lightning definitely strikes twice. In fact, it's been hit more than 18 times since it was built.
So the main challenge of any tall building is to figure out how to take that lightning, run it down the side of the building without letting it get inside the building, without letting it penetrate the building, until it can harmlessly reach the ground and cause no problems.
I'm not too much scary to go there.
At the top of the spire is one of the most sophisticated lightning protection systems in the world. Today, one of the rope access technicians is going to check it for damage following a recent storm. It takes even an experienced climber nearly an hour to reach the top of the spire. Sensors on this lightning rod anticipate when a bolt is about to strike and send out a stream of charges to attract the lightning towards the rod, which works well if the lightning strikes the top.
Because the Burj Khalifa is so tall, lightning doesn't just strike at the top. It can strike anywhere across the building. It needs to be lightning-proof all around it.
Luckily, the tower has a hidden trick up its sleeve. The entire metal exoskeleton of the Burj Khalifa acts as a Faraday cage, drawing the lightning to the ground around the outside.
And this Faraday cage directs that electrical current around all the important stuff, the electronics, the people inside the skyscraper, without damaging anything inside.
The protective engineering has kept the Burj Khalifa safe for nearly a decade. And in this time, it has become a global icon.
The effect of this tower is immense. If you go out to the lagoon next to the building, any evening, every day of the year, there's thousands of people there to see the building, see the fountain, see the lighting show. It put Dubai on the world stage.
Started with a dream, and then a journey of seeing that dream every day getting built high and high and high.
From its unshakable foundations to the rock-solid concrete core. From its extraordinary protective skin to the ingenious solutions that allow it to function, this tower is an engineering marvel.
We're still the best, we're still the highest, we're still staying up there.
On my way here, walking over to the building this morning, I stopped to take a picture of this building that I know so well. I just have to. It's just quite remarkable.
The Burj Khalifa is one of the greatest superstructures ever built.